In terms of impact strength, 20% it is showing almost kilojoules for 14.47. That's a good sign for any product. But when the increases and there is a viscosity play a role, and viscosity increases, there is a reduction on the impact strength. And tensile modulus obviously increasing the addition of wood composite. Now, when you are going for a comparison between the FGT technology standard with the case studies of PBAT lignin, okay, it is a recycled PBAT. It is not a virgin PBAT. We have taken the recycled PBAT and again used for value addition. The recycled PBAT for the value addition, we've added lignin into that. Our main intention was to uh, incorporate more and more lignin and better dispersion and also smooth stand surface. This was the literature study when we did for a virgin PBAT. The PBAT 60% and the lignin was 48%. We observed tensile strength 14.4 and elongation 378 from the, and if you see the virgin here, virgin almost 816 elongations. We have added PBAT from the intake and melted completely, added lignin from the second side feeder. This was the our fractional geometry technology we have utilized, and also same process we have utilized the standard technology. I had just given the example only fractional geometry technology. We have used smaller extruder 25 millimeter in the lab, added lignin 17% in 29. But the next slides I'm talking only on the 29% property, mechanical property. These two combination we have utilized, and if you compare the FGT technology and standard, there is a difference here. The torque, the standard is giving a little bit higher in the torque, but the power consumption also higher, and specific mechanical resistance is higher. And when you compare to the melt temperature, almost 15 degrees better in FGT technology compared to standard technology. This was the lignin powder, okay, on the right hand side. After lignin with the PBAT, the compounded pellets was looks like, and it was compact and better elongation. When we did the SAM study on the PBAT and lignin with 29% of lignin with the remaining PBAT, we observed there is a lignin at the top layer of the lignin was completely distributed into the polymer matrix like a PBAT. But in the case of standard technology, it was not completely distributed on the wetting was very poor, what we observed, because still I can see the polymer, and the lignin was not completely homogeneously distributed in the standard technology. That could be the reason, maybe the lower in the mechanical property in terms of standard technology. We are here, the PBAT was here, and when you compare with the thermal stability and also shear rate, when the addition of lignin, the thermal stability of the PBAT was improved. That shows it the lignin had a better thermal stability, and share rate was reduced when the addition of, that is also good thing. Share rate was reduced because with the virgin PBAT was the thermal stability is here and also share rate here, but there is a addition of lignin, there is improve in thermal stability, reduce share rate. That gives the, even though polymer screw friction reduces, that is gives the indication it lubricating the lignin was lubricating into the polymer. And again, the viscosity, obviously addition of lignin increases the viscosity. If you compare with any mineral filler, when the addition of calcium carbonate and any other stuff, when the viscosity increases, there is an increase in the shear rate. But in the case of lignin, it's a reverse. when you compare the P-bar, was we observed 15 kilojoules per meter square, the virgin sample, the standard technology showing us 36.7, but FGT is giving better than the impact strength. But here also, if you see the wood composite, when you added a P-bar, there is a reduction in the impact strength, lowers the impact strength. But in the case of lignin, increase in the impact strength. In even for a standard and FGT, both there is an increase on the impact strength, and flexural modulus also increases. In the P-bar virgin, we have 100 MPa, but there is a slight increase, almost 3 times the when the FGT, using FGT gives you the increase in modulus. Final results when you compare all, and that's what I explained already. The impact increases, and in the case, finally conclusion, FGT is giving better mechanical property compared to the standard technology. Yeah, FGT technology showed higher mechanical properties and better miscibility in the PBAT with the wood floor and the lignin both, and it increases the tensile strength and the modulus in the wood composite. And the addition of lignin and PBAT increases the impact strength, flexural modulus using FGT compared to the standard technology. Now I'm going to the jute composite. The last one is the bamboo. I'll finish with the bamboo, I think. Okay. Again, similarly, we have taken for polypropylene with a different jute 30, 40, and 50% loading with the polypropylene, and also use MAPP coupling agents. We have used to, our aim is to better mechanical property and the wetting of the jute fiber. It's a complete yarn introduced into the extruder so that we can maintain the better mechanical property. And we have used the same twin screw omega. We have used fed jute fiber from the side feeding from here, and we use 2 vacuums to remove, because we observed jute moisture was almost 20 to 25% in the initial, and we have used 30 and 40 and 50%, and also the throughput was 100 kg per hour. This was the pellets after compounding. When you did the SAM analysis, we observed some of the unweighted, and also there is a brittleness on the jute fiber. It was not completely weighted, and matrix cracking in between. We observed some cracking when you are using for a standard, but FGT is giving a reasonable mechanical property. And this picture shows the weighting, poor weighting, so that it's pulling of the fiber comes out, so that there is a lower tensile strength. If you compare the results and discuss, the polypropylene we use is 35 MPa, and the increase in 30, 40, and 50. At 50%, there is a reasonably increase in the mechanical property, tensile strength, and also flexural modulus increases by addition of jute. These are some products we did, and using jute. Now we are going to talk about the natural bamboo powder, and this trial was done at our lab, and also we have sold 1 or 2 extruder the customer is already using. And also we can color the finally different color depending on the requirement. And the benchmark what we got it from the customer, saying that it was 45 tensile strength, and steer test results are higher using FGT technology. Also slight improve on the impact strength and flexural modulus. I think can I stop from here, so that there are many are there. Okay, I think
Yeah.
Stop it then.
You can please go through. No problem. You can finish your presentation. Yeah.
Okay, I'll go fast. Okay.
Run through. Yeah.
Yeah, yeah. Then the second one is the bagas, and also we did because one of our industry came to us, and there is a wastage of bagas is going to the ash and all, and then we try to utilize to convert into the useful things, and this was the final property after using twin screw. The right hand side is the compounded pellets, and this was the bagas, and we use treated and untreated, but not much difference between the treated and untreated. But and finally we started using untreated bagas, and this was the tensile strength was very low, but flexural model is good. It depends on the application we can select, but interestingly the HDT was giving better, 145. That was a good thing. In 20% of bagas, we have used 20% of bagas, and we use hemp fiber, also similar. It is like a sixth case studies, and what we brought hemp was completely, it was agglomerated and difficult. We uh, distribution was such a nightmare, and because it absorbs more moisture, and finally we didn't pre-dry, we just separated in high speed mixture and started using these were the pellets, and I don't have much detail on the properties. We are still working on. Second is rice husk. This is a similar category. One more. Okay, thank you. This is our application development center in Bangalore. If anybody interested, you can come to steer, and definitely will help you to work with you. And this is our US lab, and this is Japan lab. Thank you so much.